Okay, so we have looked at, excuse me, what the discriminant tells us and how it talks to us. Um, Now we're just going to do some work on calculating the discriminant and interpreting it to tell us how many solutions our equation is going to give us and what type of solutions they will be. So let's take a look at that. One of the reasons that it does what it does is because the discriminant is actually under the radical, kind of like I explained at the end of the last recording. So all the rules of radicals apply to the discriminant about negative values, positive and negative roots, things like that, and that a square root is a type of grouping symbol. So we have to do what's under the square root before we can do anything else. So I forgot to add that part. But another reason that this really is helpful for us is because if we recall back to when we first started talking about quadratic equations, we were talking about how we were finding the solutions, the roots, the zeros, things like that. And those solutions of quadratic equations are the actual x-intercepts of our graph when we graph the quadratic equation. So if our discriminant here, I need a pen. So if our discriminant right here is comes out to be positive, then we will get two separate solutions. Now it's not saying whether these are real solutions or, rational or irrational, but it doesn't matter because irrational and rational numbers both fit on the number line, the same number line. So this is showing that it could be either or either or. So that's one of the reasons why this is really helpful for us. Now over here, in the middle one, is this one right here. This one's really interesting because when we have quadratic equations and when we graph them, we always get this kind of a shape. It's called a parabola. And I will spell that for you with a smaller size pen. It's called a parabola, or we might want to call it a parabola. No, it's a parabola. And it always is a U-shape. It's always symmetrical. So when we have a discriminant of 0, we're going to get one solution. It's going to be rational, and it's going to be at that vertex of the parabola. So that's why there's only one x-intercept. Now, when our discriminant is negative, well, we don't have any real solutions, so it can't cross a real number line. So we're seeing something that's floating above the x-axis. That means there are no x-intercepts. So let's take a look at some. And we're going to look at this equation and use the discriminant to see what kind of solutions we're going to get. I don't know what color to use. Let's see. How's this look? Oh, that's pretty cool. All right. So our discriminant is just that thing under the radical. So we have b squared minus 4ac. Here we have a, here's our b, and here's our c. So we take our b, so that's 13, and square it, minus 4 times a, which is 2, times c, which is 15. And then we just keep evaluating. 13 squared happens to be 169 because that's one of those things I had to memorize. Let's see. 15 times 4, that happens to be 60. 60 times 2 is 120. So we are going to get 49. If I did that right. Let's see. 30 times 4 is 120. Yep. So our discriminant is 49, which happens to be a positive perfect square. So a positive perfect square, if we remember, means that we are going to get two rational solutions. So we are going to have two x-intercepts, and we don't know what the solutions are, but we know that we're going to get two rational solutions. So that's a great way to check when we use the quadratic formula if we are actually getting two rational solutions. So there's lots of ways to check what you're doing. It's always a great idea to do that. Now this one, I know if we were doing this live, I might have skipped this one. But since we're not, then I'm going to say let's go ahead and do it. So we've got an A equal to 1. We've got a B equal to -1/2. Remember your signs. The signs always go with the number. And then our C is going to be 1/16. It's fractions. It's okay. We're going to be doing multiplying with fractions most of the time here, so it's not that much to worry about. So our discriminant is b squared minus 4ac. Well, b is -1/2. -1/2 squared, -1/2, minus 4 times 1 times, that's convenient, 1/16, minus 4ac. So -1/2 squared, that's the same as 1/4, and it becomes positive because a negative times a negative is a positive, minus, this becomes 4/16. 4/16. That simplifies to 1/4. We are going to get a discriminant of 0. I love discriminants of 0. This means that we have one rational solution. If we go back to that chart, we'll see there we go. Here we are right here. Yeah. Right there in that middle one. So we're going to be okay. Now this one. This one is a little bit slippery. I'm not going to say sneaky or tricky. I'm going to call it slippery. Because what are we missing? We are missing the x term. So we can see that our a value is going to be 1. Our c value is going to be 5. But what is our b value? It's 0, because 0 times x is 0. So we could say that this is actually, if we want to say 1x squared plus 0x plus 5, which will all simplify down to that. It's okay to have a 0, as long as the 0 is not in front of the x squared, because then we don't have a quadratic anymore. So we can have a 0 other places, though. And what we're going to find out here is, use the discriminant, b squared minus 4ac. Our b is 0. 0 squared minus 4 times 1 times 5. Which means I'm going to get 0 minus 20, or negative 20. My discriminant's negative. Can I have a negative discriminant? Sure I can. It just means that I'm not going to have any real solutions. So I'm going to have no real solutions, which is okay. It just means that our graph is floating above the x-axis. So we've seen kind of one of each. And I won't get into how we're going to deal with a negative under a radical, because we will deal with that probably, probably either in the next unit or maybe in a different class. I haven't even looked that far ahead yet. So, and that is actually it. That's all there is about the discriminant right now. So the discriminant is part of the quadratic formula. Quadratic formula being x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's the stuff under the radical. And, the radical seems really important. And it is, because it is that discriminant. I'm going to just do a little thing over here, right here. I don't know if you noticed. What does that question mark say? If we look at it really, really closely, it's actually telling us the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I love saying it. So I hope this was helpful. If we need to go over how to derive the quadratic formula, we can do that again. If you need any help, come visit me during my hours, in my office hours, and I'm happy to help you anytime. So I hope you have a great rest of your day.